Hey everybody, welcome back. So today I want to talk about swing, and we're going to do this we're going to look at a bunch of different patches here and a few different ways that you can get this, and this sort of casts us in a pretty cool direction, I think, towards some future videos where we're doing basically weird stuff with rhythm, which is kind of what this channel is all about. All right, so let's start with some basics. So what is swing? It's in the kind of traditional definition, and sometimes people call it shuffle, sometimes people call it swing. I don't really know, but in the normal sense, it's going from a rhythm that looks like this, where if we take a bar and we divide it into 8 increments, and we have an event on each of those evenly spaced increments, that's straight timing. But swing timing is when we take those events and we space them differently so that every other event is kind of pushed back in time off of the increment. So let's look at a few ways to do that. One is with this object called swing, which is available with Max since version 8.3. If we pass a phasor into it, let's make that a unipolar phasor. And make it a little bigger. And we start the phasor. It has this swing attribute. And when that value is at 0.5, you can see that basically we're getting the same thing as subdiv 2. It's exactly the same when that swing parameter is at 0.5. But as we change this subdiv, or swing parameter rather, then we kind of stretch one of the phasors out and make the other one shorter. If we then pass that into a what tilde to give ourselves an impulse, which will drive this synth that I'm using that I borrowed from the Go book, you can see that we're getting 2 closely spaced events. Of course, this is only swung half notes. So if we want to keep the same phasor frequency and have 8th notes or 16th notes or something else, then we will just stick another subdiv in front of it, and then we'll subdivide that one to half whatever increment we eventually want. So if we want to have 8th note swing, we're just basically going to say 8 over 2 is 4, and we're going to pass div 4 into a subdiv object and get this 8th note swing. Cool. So that totally works, and if you've kind of got the answer you're looking for, you can stop watching this video. But there's all kind of another direction that we can go, and another way we can implement this that I think brings us some really interesting results. And to talk about that, I'm going to come back over to this set of diagrams. And down here I have a depiction kind of a phasor. And these dots basically represent the events that we would have if we subdivide that phasor into 8 increments. And basically, we have 8 rows and 8 columns. And anytime we cross the row marker, we're going to get an event, right? So the amount of time that it takes basically on the x-axis for us to get to the next row marker is, we could think of that as being the interval between one event and the next. So this is normal straight timing like we have here at the top. But if we want to move to swing, it might look something more like this, right? Because if we flatten this line out a little bit, lower its slope, decrease its slope, we're going to reach that y-axis point, that row line, at a different point and kind of push that event back in time. If I depict some subdivs here, we can see that on the straight timing, the length in time of each subdiv is the same for each of these, and the length of the y-axis, of course, is the same as well. If I add those same lines in for the swung, you can see that the x-axis is much longer for these events that come with the shallower line. And this is kind of basic Pythagorean theorem type of stuff. So basically what we can do to create swing is do a similar thing where we kind of kink this line as it goes in order to create swing. So let's get into doing that. So I'm going to create a subpatcher here. I'm going to call it swing. I'm going to create an inlet for the phasor and an outlet for the new phasor, the kinked phasor that we get. And then I'm going to create additional inlets for the subdivision that we want, basically whether it's 8-note swing or 16th note or what have you, and then the swing amount. And I'm going to create a live.scope so that we can see what's going on. Oops, I think I made a mistake there when I made that. Yep. There we go. And if I start our phasor and connect it, oops, where's my inlet? Oh, I used like Gen style or rainbow style inlets because I've been doing so much rainbow and Gen lately. There we go. Okay. And you can see we're getting this phasor. So we already said that we want to change the slope of the line, right? We want to make that slope either flatter or steeper on some alternating, like on an alternating fashion for each subdivision. So first let's get that slope, and we can use that by using the delta object, which basically takes the current sample minus the prior one. So if we create another live.scope and we display what's coming out of that object, what we're getting is this line here is actually very, very slightly above 1, which we could see if we pass that into a number box. But then every once in a while we get a number that is -1, which is when the phasor wraps. So let's eliminate that -1 so that we just get a consistent value slightly above 1, or slightly above 0 rather. And a clever way that we can do that, which I recently learned from the Go book, is to use a wrap between -0.5 and 0.5. You can see that the result is now going to be basically always the same. I think there's one sample where it's at 0 because it will wrap -1 around to 0, but it's just a really clever way to kind of get that -1 out of here. And the reason that we're going to want to do that is because eventually we're going to add these all back up. If I take another scope here, a unipolar one, and I connect it to this plus equals tilde object, which is, it's called an accumulator. Basically, it's going to take every sample that comes in, and it's going to add it to sort of a running total. So if you watch what happens as I connect this Pong object to the accumulator, watch what happens down in the phasor that's down here. And also, I'm going to zoom in for you because I realized I didn't do that. We got a little ramp. I can reset that running count by passing a click or any kind of impulse into the second inlet. So I'm going to do that. And you can see we're getting another ramp. Okay. So I can automate that click that resets the running count back down to 0 by, after our delta here, adding a less than 0, passing that in there. And the result is that we're going to get a phasor between 0 and a 1. So basically, we just recreated a phasor. We took a phasor, we broke it apart, and we recreated it. Well, why did we do that? The reason is because at this point, we now have the power to change the slope of that line by scaling that slope value. So if I multiply that by 1, I'm going to get the same thing. But if I multiply it by 0.75, I'm now going to get a shallower line that only goes from 0 to 0.75. So now what I'm going to want to do is basically alternate back and forth between some value that is below 1 and some value that is above 1 in order to get this kind of kinked phasor like we have on this red line, right? Because 1 is in the middle here. This is shallower than 1, so multiply by less than 1, and then this segment here is greater than 1, so we're going to multiply by more than 1. Where am I? Okay. So let's get into doing that. So if we take here a swing amount into the third inlet, and we want that we expect that value to be between 1 and -1. And then what we're going to do is, and 0 is going to be no swing. So it's going to be value between -1 and 1, and 0 is going to be no swing. And what we can then do is first we're going to turn that into a signal so that we can work with it a little more easily. And then we're going to just add 1 to it. Then we're going to take another one of these and we'll multiply by -1. So we'll basically invert it, flip it around because it's a value between, 1 and -1. And we'll add 1 to that. And the result that that's going to give us is if we pass 0 in, like we have right now, then we just get 1 on both sides. But if we increase that value, then we get a higher value for the first one and a lower value for the second one, but they're both the same distance away from 0. Okay, so then if we add a selector object, selector, there it is, with 2 inlets, we can pass 1 into one inlet and 1 into the other. And selector basically just takes into its first inlet a number that tells it which of its other inlets to pass on. Right, and so that's going to be a 1 or a 2, and we basically want to alternate back and forth according to whatever subdivision the user of our patch specifies. So we're going to add a subdiv in here, and at the inlet here we're going to put prepend div because what's coming into this inlet is going to be some subdivision. And I'll come back over here and do that. Oops, that's a gen patch. Where are we? I'm lost. Ah, there we go. Great. Close those audio settings. So now the result is we have this subdivided phasor. Or in fact, we need to first connect the input phasor to it. And more importantly, from this second inlet, we get a counter. We get a counter of how many subdivisions have passed. We can take the modulus of that, which is basically the same thing as this pong, except it just uses 0 as the bottom value. So it's going to be ponging between 0, or wrapping between 0 and 1. And then we'll add 1 to that. And then that is going to alternate between our 2 slope values. And you can see that now we're getting this nice kinked phasor. If we then send that to the output, I'll visualize it again over here because it looks cool. We add another subdiv in. And we want to set the subdivision to the same value as the one that's inside the swing patch. And then a what object. And if we see what that ends up looking like, we have these narrowly spaced events, and we pass that in, and we can hear the result. So that's super cool. There's one more thing I want to show you, which is sort of something that's possible now that we have this, this concept. So I'm going to copy this subpatcher that we have here. And I'm going to come over here. And what we're going to do is instead of using a single value that gets kind of alternated the way that we've built here, instead we're going to use a multislider to basically set these deviations away from the middle and end up with a line that looks pretty crazy. Okay, so I'm going to come in here and I'm just going to rearrange things in here a little bit. So we're going to take just one inlet because we're going to get, I'm going to delete a bunch of stuff here. we're going to get a multislider list in, and that's just going to be a list of numbers between -1 and 1. Oh, I have a little invisible one here to give us this middle line, just so we can see where the middle line is, and that's what I was connected to. There we go. So I got a bunch of values between -1 and 1. And I can take the length of that, and I can use that to decide how to subdivide right off the bat. If I then start the transport and I send that list in, you can see now we're getting a count. And then basically I want to make it so that these values are kind of centered around 0, because like we saw with the example where we were just using this swing amount value, we made sure that they were equal distance away from 1. And the reason that we want to do that is by making sure that when the values all add up, at the end of the phasor ramp, they resynchronize at 1, right? We don't want to have it happen where our phasor ramp is like shorter or taller than 1, at least not in this particular example. Maybe that's interesting to you, but in this example, we're going to have it be so that there's all this variation happening along the slope of the phasor line, but when it actually gets to 1, it resets in phase with our original phasor, okay? So what we're going to do is take that length, and we're also going to take the sum, or I'm sorry, yes, the sum of those values. And I'm going to use a trigger object to make sure that we're always getting the length before we get the sum. And then I'm going to divide the sum by the length. So basically, we're going to take the mean of those values from the multislider. And I need to zoom in again. So if I come over here, and I'm going to actually set things up so that it's easy for me to do both at the same time. Great. If I play around with this, then I'm getting the mean value of all of those. So if I then subtract whatever that mean is from each and every one of those values, then I can center them all around 0. And the way that I subtract a list from a single number like that is with the vexpr object. So I'm going to say vexpr f1, which is going to be the value into the first inlet, minus f2. And because the value into f2 is a single number, I'm going to use the at scalar mode 1 attribute. And then if I send a new list in, you can see that these values are offset slightly from what came in by 2.43363. And just to prove to you that this worked, if we then go and take this mean again of the offset values, you can see that that's 0. Okay. So now that we have those, what we can do is pass those into a stash object, and we're going to give that the mode 1, and we're going to pass the output of the subdiv into the third inlet, and we're going to pass the scaled or the offset values into the first inlet. Or I'm sorry, we're going to pass the list into the first inlet, and we're going to pass the output of our subdiv into the third one. And the result is that every time we have a new step, we're going to get a new value from that list. So now we can simply patch that directly into our scalar here. And the result is that we're going to get a line that wiggles quite a bit. And we have a bug here, and let me think about what it might be. Oh, I know what it is. We need to add 1. So we need to get between 0 and 2, not between -1 and 1. So within our vexpr, we're just going to add 1 here. And then I'm going to send a new list. And there you go. You can see we're getting this weird wiggly line. And now if I send that into subdiv and into what? You can see that we get these strange So this is a way that you can pretty reliably modulate time and get some weird stuff while still kind of always coming back to the foundation of your original phasors, because these are always going to be completely in phase with one another. And I can prove that to you in an interesting way. So I will make these so that they're the same size and shape. And then this top one here, I'll make it transparent. Oops, transparent. And then I'll make the line a different color, white. And you can see that the kinked one is kind of wiggling around the straight one, but they end up in the same place and they always reset at the same time. And this is kind of an approximation of the bouncing ball rhythms, very primitive one. And here we can also sort of decouple our swing from our increment. So if we stick with the eighth notes, but then let's say we make this a way bigger multislider with maybe like, I don't know, 128 sliders. And again, I did the same mistake I did before. There we go. 128. You can see that we're getting a much smoother sort of wiggle there. And then we have the flexibility. Once we've set this modulation, then we can kind of change to whatever subdivision we want to use. That's it for today. If you're enjoying these videos, please like and subscribe. Let me know what else you want to learn about here. I think there's a ton of directions we could go. We could do this whole thing in rainbow, which I know a lot of you are interested in. We could do it in gen as well. We could also just get into some more of these weird modulations and explore into this terrain of just doing strange things with clocks. So let me know what you're interested in, and I'll see you next time. Bye-bye.